Right, what we're going to do now is we're going to look at how we can use a chain rule to differentiate composite functions. So we've been given a function f of x equals 2x cubed minus 1, g of x equals cos of x. And they want us to find the rule for f of g, they want us to find the rule for g of f, then they want us to find the derivative of g of x at g of f, and then the derivative of f of g at pi on 3. So stating some rules, finding a derivative at a point. So let's see how we do that. So f of g means that we've got f, and then instead of x, we're going to write g of x in there. So that becomes, so for a, fog equals 2, and then instead of x, we're going to write cos x. Cos x, that has been cubed minus 1. For g of f of x, that means we're putting in g of x, which is cos x, and we're replacing x with f of x. So if this is for part B, So for part B, we have cos, and instead of x, we're putting in 2x cubed minus 1. So that's what we've got there. So that's g of f. Now, in part C, we're asked to find a derivative of this thing here. So what we do, we will replace 2x cubed minus 1. We replace this part here with u. So we're going to say u equals, not cos, sorry, 2x cubed minus 1. So now from there, y, we're going to call it y, equals cos of u. So the derivative of that, dy du, is negative sine of u. And the other thing we need to do, we need to differentiate this. So du dx equals 6x. Get a little closer in. And now, like we know, we're using the chain rule, so we're going to have to multiply both of these two derivatives. And we're going to have to place this u with what u equals. So over here, I'm going to say that finally dy dx equals negative 6x sine of 2x cubed minus 1. So that's what we end up with there. Okay, since it's just jumped, just go back and have a look at what I just did and pause the X. Now we're looking at part F. So in part F, they're asking us to find the derivative of f of g at a point of x equals pi on 3. So this is what we've got. That's fog, f of g of x, and we're going to differentiate this. So to differentiate that, we've got y equals 2. We're going to let cos x equal u. So we've got 2u cubed minus 1. So then dy du equals 6u squared, and du dx equals negative sine of x. So then we multiply both of these to find our dy dx. So then we say dy dx equals 6u squared, negative because we've got a negative here, sine of x. And we know that u equals cos of x. So we go to negative 6 cos of x, and it's got to be cos squared of x times sine of x. So from this, now we need to replace x with pi on 3. So we'll say negative 6 cos squared of pi over 3 times sine of pi over 3. Now, cos of pi over 3 is a half. I'm going to square that, and then I'm going to multiply by negative 6, so we've got negative 6 over 4. Then I'm going to multiply that by sine of pi on 3, which is root 3 on 2. So from there we end up with negative 3 root 3 over 4. And of course that's something you can check with CAS.